Good morning, everybody. Thank you for joining me on this session. Now, let me just get rid of my video so it doesn't take up too much of the screen. There we go. Right, let's get started. So, first of all, thank you very much for joining me on this session. I'm going to take you through the latest releases of Vlocity and Diskeeper, so ignore what it says on the slide there. I'm going to include Diskeeper as well today. I'm going to include a live demo and show you what the latest features are in the latest versions of the software, and really try and show you why it's worth getting onto these latest versions of the software. Now, this is one of my least favorite slides. I'm not going to go through all of the details here because there's too many words for a slide deck, in my opinion. But some of you, obviously, you're all customers. You know who Conducive are. You know the background, so you don't need too much detail here. But some people may be using older versions of our software. And may still think of Conducive as a sort of defrag solution. Now that changed many years ago now, actually. You know, doing an old school defrag in today's environments really is not a sensible thing to do in a lot of cases. It's certainly not something that I would recommend in today's corporate environments. So we shifted our technology maybe 5 or 6 years ago now, something like that, so that instead of focusing on defrag as we had done historically, we changed the software very much to reducing the amount of workload that the back-end storage has to deal with, which is very beneficial and very efficient, and also focused on RAM caching to really help the performance of those storage-hungry applications. And I'm thinking of things like SQL Server, Oracle, SAP, file and print servers, document management systems, CRM systems. Anything that's doing a lot of storage I/O traffic will, I'm quite certain, benefit from the type of technology that's in today's versions of Diskeeper and Vlocity. One question I get asked quite a lot is, what actually is the difference between Diskeeper and Vlocity? And I'll let you into a little secret. They both actually do the same job. The distinction between them is more of a marketing one, really, because people historically remember Diskeeper as being for physical Windows servers. That's what they associate with the brand. We have the Diskeeper brand for, of course, physical Windows servers, and of course you can even run it on laptops and workstations as well. And Vlocity is marketed for the virtual environment. So for those who are running VMware or Hyper-V or KVM over Red Hat or Citrix Zen Server or something else, that's the brand for them. But actually, the products both do the same job. They both have a very similar code base, and they share a lot of the same technology to do things like RAM caching and I/O reduction, and I'll go into that in a bit more detail in just a moment. But if you didn't know, as a company, we've been around since the early 80s, a very long time for a software company. We first started producing software back, gosh, in the old VAX VMS days, and hopefully you're all too young to remember that far back. I unfortunately am not. We started producing software for Windows in the mid-90s when Microsoft brought out Windows NT 4. And what some of you might not know is that we co-developed with Microsoft the Move File API that's actually still in the Windows operating system today. So it's still there in Windows 10 and Windows Server 2016, and it's not going anywhere anytime soon. Basically because when they brought out Windows NT, some people were still using a FAT32 format, and some people were embracing the new NTFS format. But there was an issue at that time that fragmentation did cause performance loss. Now, of course, we had a very successful solution in Diskeeper, which we sold a lot of licenses of over the years. But as those environments matured, now you have different technologies that really just weren't around back then. So I'm thinking of change block tracking technologies like replication, deduplication, copy on write, snapshots. And when you're using those types of technologies in your environment, which a lot of people are these days, it really isn't beneficial to do an old school defrag in those types of environments. I mean, if you think for a moment, if you've got a volume that's a terabyte in size, and you were to do an old school defrag pass over that entire volume, what's happening? Well, it's looking for fragmented files that have been split up into pieces over that NTFS volume, and when it finds them, it'll make a defragmented copy, hopefully at a lower logical cluster number or LCN, in order to avoid bloating a thin provisioned volume. Not all defraggers even today actually care about that, which is a bit naughty in my opinion, but you then have this defragmented copy. It then uses a checksum to make sure that the defragged copy is exactly the same as the original. And if that all checks out, then it removes the original, and you're left with the contiguous or unbroken copy of the file. And it works its way through that volume doing that. Now, if that volume is a terabyte or more in size, first of all, that's going to take a long time. It's going to use up quite a bit of compute taking care of that. But it's also going to cause a lot of excess unnecessary overhead to those change block tracking technologies. If you're making that many block level changes as you're running the pass over the terabyte sized volume, that's going to cause a lot of extra overhead to things like replication and deduplication that are only taking into account block changes. Or, for example, your next snapshot is going to be way bigger than it actually needs to be just because the blocks containing the data have changed elsewhere. So running an old school defrag in today's environments is really not something that you want to do. And I think most people don't these days. So we wanted to stay relevant, of course, so we shifted our technology to make it focus more on application and system performance so that we can increase the performance and really squeeze every last drop of performance out of the systems you own. And really reduce the amount of workload that the back-end storage has to deal with. Now, why is that important? If you think of your IT infrastructure as a stack, you'll have your storage layer at the bottom, which could be a storage area network or SAN. It could be a NAS drive. It could be comprising of direct attached disks. They might be SAS drives, SCSI drives. You might have a tray of SSDs or be fortunate enough to be running an all-flash array. If you compare the speed at which things can happen down at that storage layer with the speed at which operations can happen at a CPU or processor layer or in server-side DRAM, even if you've got an all-flash array, it's still going to be the slowest part of that stack. So the more we can reduce the workload on that, and the more we can leverage that server-side DRAM for caching, the better those applications are going to perform, and quite simply, the more work you're going to be able to get done in the same amount of time using the existing infrastructure you already own. Now, hopefully, that's a story that's familiar to most of you because you are customers, but I wanted to mention that just in case we've got anybody on the call who still thinks of us as a defrag company. We're really not, and I'm going to take a quick deeper dive into the technology in today's versions of the software to really help you understand that. And then we'll switch over to a live demo because nobody likes PowerPoint. Live demos are always much more fun. So just before I flip off onto this, I just wanted to mention that I'm very proud actually of this Microsoft SQL Server I/O reliability certification. We got that last year, and basically what it is Microsoft have certified our software, our technology for use with Microsoft SQL Server. Actually, they did some tests running SQL 2016 in a machine in Azure in the cloud. They ran an online transaction processing type workload to sort of let the SQL server do some work. And aside from being able to jump through all of the hoops that were necessary to get that IO reliability certification from Microsoft, we actually showed that we were able to allow SQL Server to do 30%, roughly, more transactions per hour per day than it otherwise would be able to do, which is pretty cool. You know, if you think, if you're an online trading company or an online shop, there are periods of time in the year where you might have to spin up more SQL instances to cope with the workload. So think about the lead up to Christmas for a big department store, for example, that's also selling online. If you can squeeze 30% more SQL transactions out of each SQL instance, well, you might not have to spin up so many SQL instances, and that could represent quite a saving, especially if you're running those workloads in public cloud like Microsoft Azure or AWS. So yeah, I was very pleased to get that certification. And as far as I'm aware, so far we are the only, and certainly we were the first, software-only solution to achieve that certification. I think the other guys that have got it are more the storage hardware vendors. So yeah, very cool. Some of the technology that's in today's products, and usually the caching technology, which I'll go into in a bit more depth, has been OEM'd to some of the top hardware manufacturers. So we've got a couple of storage companies. Typically they use that with their hybrid drives, which are part spinning disk and part SSD, to figure out what the hot blocks of data are that actually need to be on the SSD part to give the system that they're installed in the best performance. And some of the other guys like Samsung, HP, Dell, Lenovo, and others, they use the caching technology to make their high-end ultrabooks and laptops run very fast, and more importantly, stay running fast. So we'll go into that technology in a bit more depth. I'll just show you quickly what it is that we're solving or improving. The main crux of the matter is that Windows doesn't tend to interface in an efficient way with the storage. There are a lot of inefficiencies that creep in that we can simply avoid with our software technology. So to help me explain that, on the screen I've got a rough example of a virtualized environment. In the middle here we have a hypervisor. So this is your physical host. This is the VMware ESX server, or a physical Windows server with a Hyper-V role. And it's hosting a number of virtual machines. Now these could be running applications like SQL, it might be a file and print server, it might be a SharePoint server, it might be a web server. The point is, they're all doing their different workloads, and they're generating storage I/O traffic that's being funneled down through that physical host and then onto the storage at the back end. And the storage, certainly in a virtualized environment, is typically going to be a SAN, or it could be direct attached disks that are actually in the hypervisor physical host server itself. So this is what it looks like when everything's working well and running efficiently. And by that, what I mean is you have the least number of storage I/O packets carrying the most amount of data. And what that means is when that data arrives down at the storage controller, it's arriving in nice large chunks at a time. And that gives the storage controller the opportunity to create nice large stripes across its media using the least number of storage level operations before it can acknowledge that write and send that acknowledgement back up to the relevant operating system and say, yep, I've saved all of that data for you. Now, when you're running Windows in these virtual machines, this is not, unfortunately, what you're typically going to get. What you'll get is actually going to look more like this. So what's happening here, and why is this less efficient? What's happening here is the NTFS file systems that you have mounted in these virtual machines, so your C drive, your D drive, your E drive that you've got mounted in there as volumes. As they mature, as you and your applications create new files, delete files, extend files, and generally move data around on that NTFS volume, what will happen is the free space will become more and more split up into smaller and smaller free space extents. So what happens then is the Windows write driver gets given a right to perform. It goes to the Windows free space cache and says, hey, free space cache, I've got a right to do. Where's my next available free space extent? It then gets given that address, it starts writing the data, and then finds, hang on a minute, this free space extent isn't big enough for me to write all of this data into. So what I'll do is I'll split the I/O, I'll send the data that I have already been able to write in a packet on down to the storage. I'll then go back to the Windows free space cache, find my next available free space extent, and I'll continue writing there. So it does, and then it finds, oh wait, yet again, there's still not enough room to complete the write, so I'm going to have to split the I/O again, go back to the Windows free space cache again, find my next available free space extent, and basically repeat and repeat and repeat until it has been able to complete that write. Now, in the real world, what that means is that an average gigabyte of storage I/O traffic that should take maybe 2,000 I/O packets to complete is now taking 30,000 or 40,000 or even more to complete. And I have seen it as bad as 70,000. So what's happening is that same amount of data is getting split up into much smaller, far more numerous I/O packets. It's a bit like saying, okay, on this side of the room, I've got a liter of water, which is my data, and I need to move it to that side of the room, which is where the storage is. It's a lot more efficient to make one trip across the room with a liter-sized jug than it is to take that same amount of water and pour it into lots of tiny shot glasses, and then take the first 2 shot glasses across the room, and then come back and take the next 2 shot glasses across the room, and then come back and take the next 2 shot glasses across the room. You see how these small shot glass sized I/Os make this whole infrastructure work harder than it needs to process that same amount of data. And what it means is that as the data is arriving down here at the storage controller on the back end, it's only arriving now in very small chunks at a time. The storage controller won't understand the relationship between the packets that it's getting because the storage is too far abstracted away from where those storage I/Os were generated. So as far as it's concerned, it's only receiving data in very small chunks at a time. It can only create very small stripes across its media, and that means an awful lot more storage level operations are required to process that same gigabyte of data. So it becomes very inefficient. So what do we do to solve these inefficiencies and reduce the amount of workload that the backend storage has to do? Well, in Vlocity 7 and Diskeeper 18, we have 2 very key engines, and we have obviously the very latest versions of those engines, the cutting edge technology. The first engine helps to avoid these split I/O situations. So what it does is it adds an extra layer of intelligence to the Windows write driver so that it can make better choices about where it writes on that NTFS volume. So instead of having to go back to that Windows free space cache to find yet another free space extent that's not the right size, it'll say, oh, write driver, actually start writing here on the NTFS volume where there is a large enough area of free space to put that data in without having to split it up, or split it up the least. And of course, the software can quietly, in the background, help to generate those nice large areas of free space as well, using only otherwise idle resources. So that already gets you back to this type of situation where you have far fewer I/O packets, but which are carrying a good payload of data on down to the storage for more efficiency. I heard a really good analogy actually that was mentioned by one of my colleagues over at head office in California, and I made a mental note to mention this to you. The analogy is like this: if you imagine these I/O packets, this flow of data moving between server and storage, like dumper trucks moving dirt from one place to another. What you don't want is to have each truck with just one shovel worth of dirt in the back. You can have the fastest dumper trucks in the world, but it's still a very inefficient way of moving that about. What you do want is to have as much dirt as possible in the back of each truck so that that data can, or that dirt can flow to where it needs to get to in a much more efficient manner, and you need fewer trucks. Just makes sense. So another analogy that I like to use here is a busy motorway. Now, I know not everybody on the call is here in the United Kingdom, but we've got quite a famous motorway that goes around London, our capital city, called the M25. For those of you that have been unfortunate enough to actually drive on that at rush hour, you will know that congestion builds up heavily. And you've got lots of people sitting in their cars, sitting bumper to bumper, not moving more than about 10 miles an hour or 10 kilometers an hour if you're in Europe. Nobody's getting anywhere very fast. Now, imagine for a moment that each car on that motorway is an I/O packet, and each person sitting in each car is the data that you're moving between server and storage. What we're effectively doing with the latest technology in Vlocity and Diskeeper is taking all of the people out of the cars and we're putting them into coaches or buses, and then taking all of those cars and removing them from the motorway, getting rid of all of that congestion, so that now the people or your data can now flow to where it needs to get to in a much more efficient manner. You know, it'll help to reduce things like I/O queue depths, reduce storage I/O latency, and quite importantly, hand IOPS headroom back to the environment. IOPS is I/Os per second. Imagine that like a big water pipe, which is basically the network between server and storage going through the hypervisor. What we're doing is reducing the amount that has to flow through that pipe and making more headroom available. And what that means is that storage-hungry applications like SQL or busy SharePoint servers and the like, they can now get more work done in the same amount of time, just quite simply because they're not having to wait so much on the storage before being able to get on with their next operation. So that's quite beneficial. It also means that you can now host more machines, more workloads, more instances of SQL, more users processing data than you otherwise would be able to over that same shared storage. What you didn't have to do is upgrade or replace any of the hardware. We're just making what you already have far more efficient so that you can do more with it. So that's very good from an efficiency point of view. But what about performance? Of course, that helps performance. But what helps performance even more is the RAM caching, which has been improved. We've got some new caching engines in Vlocity 7 and Diskeeper 18. So what that does is use some of the idle available memory that's sitting in these Windows machines. And by the way, of course, we're looking at a virtualized example here, but the same technology applies equally well to physical Windows servers as well. So we're using some of that idle available RAM that's sitting there in those Windows machines, not being used by anything else, to set up a RAM cache from which we can satisfy a good percentage of the read I/O traffic. Any writes that occur will go straight out to the storage as they would as if our software wasn't there. But by satisfying a good percentage of that read traffic, it means two things, two main benefits. One, it's a further reduction on the amount of workload that the storage has to deal with because we're actually satisfying those read requests from within the Windows operating system itself. And two, those reads that we can satisfy from the cache are satisfied at the speed of server-side DRAM rather than the speed of the media in the back-end storage. Now, from a performance point of view, that's really helpful. If you've got if you've got a good percentage of that I/O traffic coming from DRAM, well, DRAM is roughly 10 times faster than SSD drives. You know, it's hugely faster than spinning disk drives like SAS drives or SATA drives or SCSI drives. You know, significantly faster. So the more we can satisfy from the RAM cache, the better the performance of those applications is going to be. So I hope that makes sense. As we're going through, please do feel free to put any questions that you might have into the Q&A box or the chat box, and I'll have a look through them at the end, and be more than happy to have a technical Q&A. And please don't be shy. If you have a question, there's a very good chance somebody else might have that question as well. So feel free to throw them at me, and I will do my best to answer them all. So to briefly recap, in both Vlocity and Diskeeper, so this is Vlocity 7 and Diskeeper 18, we're providing these large, clean, unbroken writes that have a greater payload of data with every I/O operation. We're caching the hot reads from the idle available RAM, and we've got new reporting or improved reporting that actually shows you how much storage I/O time you're saving. So I think that's probably a good point to let's get rid of the slide deck, and we'll switch over to the live demo. Let's put that down there. So I'll just make this a bit bigger because it might be a bit small for some viewers. Let's just scale that up. Oops. Now, there are several new features in both Diskeeper and Vlocity, which is very important to mention. The first one is, for years and years and years, customers have had to reboot their computers after installing Diskeeper or Vlocity before it could become active. Even when you were upgrading, you would need to reboot. With Diskeeper 18 and Vlocity 7, I am genuinely delighted to tell you that the reboots are now a thing of the past. You can install Diskeeper 18 and Vlocity 7 without having to reboot your systems. If you're upgrading from earlier versions, as long as what you have installed at the moment isn't too old, you can upgrade them without having to reboot. So with Vlocity, you can upgrade from Vlocity 5.3 or later. So if you're running Vlocity 6, you can upgrade without a reboot, and 5.3 you can upgrade without a reboot as well. Of course, if you're installing onto new systems that have never had our software on, just install it and it's up and running in a few minutes. No reboots required. Same with Diskeeper 18. If you're upgrading from Diskeeper 15 or later, so that's 15 or 16, you can upgrade without a reboot. If you're running anything older than that, so if you're still running Diskeeper 2010 or 2011 or Diskeeper 12, you would need to uninstall that old version first and reboot the machine, and then you could install the latest version without having to reboot, and any new versions that we bring out, again, you won't have to reboot then either. Now, I think that's having to reboot has been a real nuisance, not only for customers but also for us. You know, we thought that when Microsoft started doing their regular patch Tuesdays once a month, we thought that most of our customers would probably be rebooting once a month. And so that would provide a nice maintenance window to get upgrades done of our software. Turns out, in a lot of cases, we were quite wrong about that. A lot of customers like to keep their systems up and running for a lot longer than that, and really don't like to have maintenance windows. You know, I'm thinking of things like healthcare organizations like hospitals, financial institutions, some government and military sites. They don't like to have to reboot their software, have to reboot their systems rather. So now we've got this no reboot version. It should make it really, really easy to upgrade. It's literally a few clicks and a couple of minutes and it's done. It's really not intrusive at all. We thought for some time that it wasn't going to be possible to have a version of the software like this that you didn't have to reboot systems. The reason why we always had to reboot was because we use storage filter drivers, as do a lot of software companies. Backup companies use them quite a lot, of course, antivirus and malware companies as well. And basically, those storage filter drivers can only be loaded or unloaded at boot time, which is obviously why the reboot was required. So we have a very clever chap who actually was one of the founding members of the company, and he's still working with us today, a chap called Rick Kadruvi. And he said, okay, to solve this, let's put in a storage filter driver manager, which would then let us load and unload storage filter drivers without having to reboot any further. So he did, and that's why we have the technology. Very clever chap. You know, what he doesn't know about the NTFS file system and how to optimize it really isn't worth knowing. Very, very clever man. And I'm hoping that Conducive have had the sense to patent this technology, because I know there's a lot of other software companies out there that would also like to not have to reboot to install their software. So maybe that's another OEM opportunity. Let's hope the bosses are listening. So back to the live demo. This is the new Vlocity management console, and I'll go through this, and then I'll show you the Diskeeper administrator console as well and take you through that. But let's start here as I've got it open. If you've been using Vlocity 6, you'll probably recognize this dashboard screen. So on here, we can see the total amount of I/O traffic that's been eliminated from going out to the storage. We can see the percentage of read I/O traffic that didn't have to go out to the storage. We can see the percentage of writes that have been eliminated from going out to storage. Now, I have to just point out that this is my test lab environment, so the workloads that I've been running are not a normal production workload. You can see I've been doing a lot more testing on the RAM caching than I have on the write elimination. But typically at most customer sites, I see the IOs eliminated somewhere between 40 and 60%. You know, that's half of all of the reads, roughly, not having to go out to the back-end storage. And that's really where you start seeing those performance gains. When you get to sort of 45, 50% reads eliminated or above, that RAM caching is really coming into play and really helping the performance of those busy systems. In terms of write IOs eliminated, most customer sites see somewhere between 25 and 35% of all of the writes not having to go out to the back-end storage. And of course, this storage IO time saved indicator is quite helpful as well. This is basically accumulatively, altogether, the amount of time that the storage didn't have to spend processing these storage IO requests from each of the machines that are being monitored. Now, at the moment, I'm monitoring three of my systems in the test lab. I've got a Windows 2008 R2 server here. I've got a Windows 10 VM here, and I've got a Windows Server 2016 machine here. And this little machine over here is the domain controller for all of them. So that one's not quite so relevant. I'm not monitoring that. So these are the three systems that I've got Vlocity on and I'm measuring. I can update the results, and the results will update automatically every end period of time. But I can click on update here, and it'll take a moment or two. I've got only 3 systems here, so it'll update nice and quickly. That dashboard data is also cached locally here on the management console as well, which makes it nice and quick to update. If I want to change the time frame and say, instead of showing me the dashboard statistics since I installed it, I can say, show me what it's been doing just in the last 24 hours, or show me what it's been doing in the last 7 days, or the last 30 days, the last 60 days, and so on. I'll leave this on since installation, so we've got some nice big numbers. So you can do that. If I go into the Select Systems button here, this is where you choose machines that you want to have included in those dashboard statistics. I can very easily include or uninclude machines as I want to simply by selecting them, and then hit that Save Selection, and it'll grab the latest data and display that. Why would you want to do that? Well, typically you would want to be monitoring all of your systems, I would imagine. But you might want to say, show me the data just for my SQL servers, or just for my SharePoint servers, or show me what Velocity's been doing just for my file and print servers. Well, you can do that by selecting the machines and deselecting the ones you don't want to see very easily. Another helpful thing to point out is, you see, we've got the domain here on the left-hand side. This is obviously being picked up by Active Directory. What some customers haven't seen, and I guess this is kind of our fault for not making it obvious enough, but you can actually click on the domain here and it will expand out into the organizational units, or OUs, like a tree. So that again makes it very easy to identify machines that you want to turn on or turn off here in the right-hand pane. And of course you can also use Find a System as well, and find a VM just by typing in its host name, for example. So if I try and find that Velocity one, you can use a wildcard character, and yeah, it'll just pick out that one machine. So that's quite handy. Not everybody knows about that. So I hope that helps some people. Use that expandable tree. It can be quite a good shortcut. So there's a lot more information in this screen than there was in previous versions. You get this as well in the My Environment page, which I'll show you again in a second as well. But in previous versions, basically what you saw were the FQDNs of the machines. You could see whether they were physical machines or virtual machines, and you could see what version of Velocity was installed, and obviously those machines where Velocity wasn't installed. And that was pretty much it. That's all the data it would show you. Now we've got a lot more. So all of these column headings are sortable. So I can say, okay, let's sort by the percentage of reads eliminated. Show me what machines that I'm measuring are getting the most benefit from the RAM caching. So at the moment, that's that Windows 10 machine where I've been eliminating 90% of all of the reads from RAM. Next one is that Windows Server 2008 R2 machine, 70%, and my Velocity test box, 14%. This makes it very easy to identify those systems that are getting the most benefit from the software, and also those machines that aren't getting so much benefit. So you can have a look down and say, okay, the machines that are getting the most benefit, are these the machines that I care about the most? Are these the business critical machines? If they are, great. If you've got business critical machines and you're not seeing the most benefit from those, well, maybe we can help you to get more performance gain out of it. Now, that leads me on quite nicely to this system status column. You see here we've got little green icons, little green circles with white ticks. This indicates that Velocity on those machines is operating well, it's providing good benefits, and everything's good. There's nothing holding it back at all. But you might see on some systems an orange icon or even a red icon. And what that means is, if it's orange, it means that the software is installed and it's able to operate, but you're not really seeing the full benefit of the software. Now, Velocity is working, but it doesn't have the right resources available to really make that machine fly. So it might be that the amount of available memory on that machine is too small to create a cache size that's big enough for the type of workload that you're running on that machine. So the software will tell you that and make suggestions as to how to increase the cache size and really start seeing the full power of the software. If you see a red icon, it means that one or more parts of the software isn't operational. So that could be that that machine is so strapped for memory, it's got so little free memory that it's not able to create a RAM cache at all. And so you're not seeing any benefit from the RAM cache. It may be that the management console, for some reason, isn't able to communicate with Velocity on that machine. Maybe somebody modified the ports that were open in the firewall and accidentally closed the communication between the management console and that end node machine. It may be that somebody stopped the Velocity service on that machine. So The point is, it's very easy now to just at a glance scan down that table and make sure that the machines you care about the most are getting the most benefit from the software. And if there are some that you care about that aren't seeing the right amount of benefit, well, then we can help you to identify those and correct that. Now, there's another new feature in the reporting, which is this button here, the Download Benefits button. And what that does is it downloads all of this table data plus some additional information to a simple text CSV file. So let's go ahead and do that, and I'll show you. I've got one already, a couple downloaded here already, so I'll overwrite that one with the latest data. And then there we go. Let's go ahead and open that up. So it's a simple text CSV file, so I can open that with Excel. Here we go, open with Excel. Great, and I'll just make that a little bit bigger so we can see it more easily. Let's auto-fit that. Okay, so hopefully that's big enough for everybody to see. So we've got the system names there, just like in the table before. We've got the total amount of I/O traffic being eliminated on each machine, the total number of I/Os, the total size of all of the I/Os that have been processed. This is a new field, the percentage of extra I/O capacity. This is the percentage of extra IOPS capacity that's being handed back to the environment based on the workload from each machine. So you want that to be as high as you can possibly get it. That's quite a valuable thing to have. Then we've got information about the reads eliminated, so the number of read I/O packets eliminated, the percentage of reads being eliminated, the total number of read I/Os, the total size of all of the read traffic in gigabytes, and then we've got the same for the writes. And then we've got information about the memory and how much of it we're able to use for RAM caching. So I can see on average how much memory a machine has had assigned, how much of that on average has been available, so free memory that's not being used by anything else, and based on that, what our average cache size has been. So I can see if the cache size is a bit small and I'm doing a heavy amount of read I/O traffic on that machine, well, it's probably worth increasing the amount of available memory to give us a larger cache size. Another new field is this one here, SQL Server. So the software will identify if Microsoft SQL Server is running on a machine. And it does that so that in the tooltips, which I'll show you in a moment, it will be able to say, okay, for example, memory is a bit low on this machine for the workload that is being processed. You should probably think about increasing the available memory to give us a larger cache size. But because you're running SQL on this server, if you just add more memory to the machine, well, SQL will probably gobble all of that up for itself. And because Vlocity it's intentionally designed not to compete with SQL or anything else that's running on the machine for memory, we still wouldn't be able to use that for our cache size. So it will make a suggestion and give a link to the internet to show instructions on how to cap the amount of memory that SQL can take for itself in order to leave an appropriate amount free so that we have a large enough cache size to really make a difference to the performance of that machine. Now, that might sound a bit like you're taking RAM away from SQL to give it to Vlocity. Yes, you can cap SQL and do that, but you can also add more memory to a VM if you can spare it, and then cap SQL to make sure it doesn't take the additional RAM for itself. So, are you robbing Peter to pay Paul? The short answer to that is no. You've got to have a look at the way SQL and Vlocity or Diskeeper would utilize that memory. SQL is using it for its own form of caching called buffering. And basically what it's trying to do is stuff as much of its database or databases into that buffer or cache space as it can to try and improve its performance. And if I'm honest, it does a reasonable job of that. But the algorithms that are in Vlocity in pretty much every single case will utilize that RAM far more effectively. You know, what Vlocity and Diskeeper are focusing on in today's versions are the type of read I/O traffic that tends to slow down and dampen performance the most, whereas SQL is focusing on how can I make SQL faster. By getting rid of that excess, unnecessary, noisy storage traffic, by utilizing that RAM cache, you will benefit not only SQL, but the operating system and anything else that you have running. And the upshoot is you'll be able to get more SQL transactions done in the same amount of time because SQL will be able to operate more efficiently and more quickly because it's not having to wait so much on the storage. So it's definitely something worth doing. And I've seen performance improvements specifically with SQL time and time again on many different customer systems. And it's not just SQL that this works with. You might have other database technologies like Oracle, DBase, there's MySQL, Maria. There's a multitude of different databases out there that this software will benefit. And you can also see the amount of storage I/O time saved here as well. And of course, because it's in a spreadsheet, it makes it very easy to sort the rows as you want them, apply filters if you want to, and so on. So that's quite a handy new feature for me as a sales engineer and for a lot of customers that want to really take a deeper dive into how the software is performing on each system. And it allows me as an engineer to make recommendations on a machine-specific level to say, yeah, these are the machines that you want to add more memory to, and these ones are running just fine. And these machines, they don't have a big cache size, but there's not a lot of point of adding additional memory because they're mostly doing writes, so it wouldn't benefit from having a larger cache anyway. So it's very handy for analysis point of view. So let me close that off. Don't need to save it. Now, I mentioned a few minutes ago about the tooltips. This is, again, something that's new. You can hover the pointer over these icons and it'll give you some context-sensitive information. If I go back to the dashboard, the eagle-eyed amongst you will have seen these tooltips here as well. So you can click for help on the page, you can click for context-sensitive help, and even click on the icons and it will give you even more information and explanation about what the statistics mean and what it's showing you. Now, what we've done with that is included that context-sensitive help with the product. So if you've got a sandboxed system or systems that don't have access to the internet, you'll still be able to see those tooltips and the more information. But if the Vlocity Management Console has a usable connection to the internet, it will use that and grab the latest version of that data from one of our conducive servers. What that means is if we update the tooltip data or we want to add some more or improve it, we can do that on our server and make it immediately available to all of our customers without having to reissue a new version of the software. So hopefully that makes your life a bit easier going forward as well. So of course we also have the other statistics that you had in Vlocity 6, so we can show you things like the average, minimum, and maximum for the IOs per second, throughput in megabytes per second, storage latency, whether you're more read-heavy or more write-heavy, how much storage traffic or how much storage workload has been generated and processed, show you the memory information, so how much memory on average has been assigned to those systems, how much data you've been able to satisfy from the RAM cache rather than storage, how much RAM is being left free, and how much memory is being used to cache with. Now, an interesting question I was asked a couple of weeks ago was somebody said to me, well, I'm using an all-flash array now. It's super fast, which of course they are. They're also super expensive. And he said, you know, it's great. It gives me a large amount of IOPS headroom that I can use, and I'm very pleased with it. So I was wondering, can I still save storage I/O time with Vlocity or Diskeeper? And the short answer is, well, yes, you can. You know, if I look at my dashboard here, in my system that you can't see it, but it's just down there, just to the right of me, I only have flash storage in it, and I'm still saving storage I/O time. You know, it's when you've got most back-end storage is a fairly expensive purchase. If it's a sort of mid-size or large SAN, it's a significant chunk of money that you have to lay out for that. If you've got an all-flash array or a tiered SAN with a tray of SSDs, they're nice and fast, but you really don't want to introduce inefficiencies to it. You want to really make sure you're getting the most performance at all times out of that expensive storage hardware investment. You know, think back to those dumper trucks that I mentioned earlier. You want those IOs to be carrying as much data as possible, have the least amount of IOs that you can get away with to make it as efficient as possible, and still help the performance at the application layer and the storage layer by saving that storage I/O time and satisfying as many of those IOs as you can from the RAM. And of course, you have the latest engines in there, in the latest versions of the software to do that. One of the improvements that's been made to the RAM caching in both products is that it is now much more reactive. And by that, what I mean is it can decrease and increase the size of the RAM cache much more reactively. So if you were to start up a new application that needed a new working set of pages, it's much faster at shrinking our RAM cache, handing those pages back to non-paged pool to make sure that we're never the cause of a system running out of memory, and there's always memory there for the processes, even that new one that you just started up. So that's a lot more reactive and a lot better at getting memory back to Windows for use by other things when it's needed. And also, it's got some new intelligence to dynamically size the RAM cache back up again. So at times where there is more memory resource available, we can increase the cache size again and have a larger cache, which means we can satisfy more read traffic from that RAM cache. Another thing which I should mention is, because this is a question that comes up quite a bit, how big should the RAM cache be? And that's kind of a how long is a piece of string type question, because there's a lot of variables involved there. No two machines are the same. No two workloads are the same. But as a general rule, if you've got a busy business critical server, let's say it's a busy SQL server, and it's something that you really care about because it might be the back end for a customer-facing application, or a back end to your web server, or it might be the back end to your CRM system or your business information application. You know, maybe you're running something like IBM Cognos or Microsoft Dynamics. So this is a server that you really care about. What I would suggest is give us as large a cache size as possible. You know, we can have a cache that's well over 120 gigabytes, you know, and really cache almost all of the reads if need be. But for most systems, I would say if you can leave about 16 gigabytes of available physical memory, if you can afford that from the memory that you've got on the server, that system is really going to fly because of that RAM caching, especially if it's generating a lot of read I/O traffic. If you can't afford 16 gig, well then give it 8 gig. And if you can't afford 8 gig, give it 4 gig. Now, just whatever you do, avoid having the RAM cache too small so that Vlocity can't really make that system fast and really fly. On some of the systems which are perhaps not quite as busy, then maybe give them 4 gigabytes. But yeah, whatever you do on those busy systems that you care about the most, make sure there's a large enough cache size to offload at least 45% of that read traffic from having to go out to storage. That's really where you're going to start seeing those performance gains in those applications. So I mentioned the My Environment page. Let's flip over there quickly and turn the machines on. So this is similar to that other table that I showed you before, but now it's including machines as well that don't have Vlocity installed. So again, I can sort these by column. So at the moment it's sorted by system name. I can sort it by the installed components, so I can see all together the machines that have got velocity on and the management console and the machines that don't have velocity on. Just like the other table, I can sort it by average cache size, the percentage of reads eliminated. I can sort it by system status, the amount of workload, and see which machines are busier than others, and so on. So again, this is very easy to see which machines are getting the most benefit from the software and which machines not so much, so that you can realize, are they business critical and do I need to do something to fix that? And you can also see machines that don't have velocity on yet that maybe they should. You know, if you've got a host-based license, you're already licensed to put the Velocity software onto all of the Windows virtual machines that are hosted by that licensed host. Why wouldn't you do it? You know, it doesn't make sense, especially now that you don't have to reboot the servers when you install. It's very, very simple. So I promised a live demo, so let's go ahead and do that. What I'm going to do is uninstall Velocity from this machine down here, and then I'll install it again, and you'll see no reboots are required. So let's bring up the Velocity folder here. Let's make those a bit bigger. Okay, so here's the conducive folder sitting in program files. This is where all of the Velocity install folder is. So I'm going to go ahead and uninstall that and show you that no reboots are required. There we go. So I'll create my uninstall job. And of course, you could do this through control panel, add remove programs if you wanted to directly on the machine. So that uninstall job has been created. It's there running in the job queue. And after a moment or two, we should see that conducive folder disappear without any reboots. There we go. So the job is completed. So it's now finishing up, and that folder should disappear any moment. I say any moment, but this is a live demo, so anything could happen. No, it will. It will. Maybe if I refresh that. It's still there. Oh, there we go. It's just gone. So Velocity's now been completely uninstalled. There's no service running of Velocity anymore. It's completely gone from the environment. Didn't have to reboot at all. So now I'm going to redeploy it. So let's get that ready to redeploy. There we go. So that deployment job's now been created. So now it's installing the software back on, and we should see that conducive folder come back in just a moment as the installer script does its job. There we go. So now it's getting all those filter drivers set up, and in a moment it'll start the Velocity service, and the software will be active again. It's as simple as that to install and uninstall the software. It's just a few clicks. There's absolutely no disruption to the machine, the EndNote server at all. No reboots required. If I was running SQL on here, I didn't have to interrupt that running workload in any way whatsoever. It's super quick, super easy, and completely non-disruptive. Now, I promised a look at Diskeeper as well, so let's go ahead and shut some of these down, and I'll fire up my Diskeeper machine. Let's get rid of those so I can claim back a bit of RAM. Because believe it or not, this is a workstation I'm using, not a server. So just want to make sure that we've got plenty of memory to start these systems up with. Let's get rid of those. Okay, and let's start up my Diskeeper server. There it is. So we'll bring that down here and make that a bit bigger. Oh, maybe not quite that big. Let's do it about that. Okay. Oh, let's get that logged on. Nobody look, I'm going to type my password in. There we go. Now, what some people don't realize is that the Diskeeper and the Vlocity services will actually use a delayed start to make sure that they're not getting in the way of anything else that needs to load and take resource first. So just in the interest of speed, I'm going to manually start the Diskeeper service. There we go. You can kind of just see here in this column, it's automatic delayed start, like some of the others. So that's now up and running, and of course I can open Diskeeper directly on this machine if I want to, just as I could Vlocity on a VM, and see the Diskeeper dashboard. I'll just let that start up. There we go. So there's Diskeeper running on the machine. Similar type of dashboard interface, so I can see how much I/O traffic's been eliminated, what percentage of the reads and the writes, and how much storage I/O time has been saved. Again, this is not indicative of a live running workload. This is just a test machine in my lab. We've got those I/O performance statistics and RAM usage statistics as well. And we've got the analytics graphs, so you can see what time of the day you're eliminating most of the storage traffic, what the IOPS looks like, where you're satisfying most data from cache, what the throughput looks like, and so on. There's a whole bunch of these, and you can see things like the percentage of writes eliminated, and there's one here that'll actually show you what time of the day you're saving the most storage I/O time as well. So that's all available, but that's great for this one system. But what if I have a whole bunch of systems? Well, move that out of the way and come back to my control panel machine. I'll get rid of the Vlocity dashboard and open our old friend Diskeeper Administrator. So this is the Diskeeper Administrator console. So think of this like the Vlocity Management Console, but for Diskeeper. So again, in here I can install and uninstall Diskeeper across the network without rebooting anything, just like I just showed you with Vlocity. So I won't run through that again, because watching somebody install and uninstall software is probably a bit boring the second time. But yeah, exactly like Vlocity, no reboots required, very quick, very easy, no disruption. With the reporting in here as well, we also have this benefit summary style, so I can select the machines that I want to pull data from. I can select a whole bunch of them. I won't use this dump analysis machine as well because I haven't got it turned on, but I'll just pull it out of here. But again, you can select machines to say I want to see what Diskeeper's been doing on all the machines. I can say, show me just what my SQL machines, what benefit they've been getting from Diskeeper, or just the machines for the accounting department. Or just even for a single machine, as I'm going to do here. So then I can hit this Start Network Scan button. It will go out to that machine, capture the latest dashboard information, and present it. So if I'd done a whole bunch of machines, I would see an accumulative report here of what Diskeeper's been doing on all of the machines that I selected. You have the normal information here. You've got Tooltips, again, like I showed you in the Vlocity Management Console, and you can click on those to get even more detailed explanations of what you're seeing. You have that same I/O performance data and the analytics graphs as well. Expand all those out. You could also use this View System Status button up here to view the data, just like in Vlocity, as a table, and you can export that to a CSV file as well, just like we did with the Vlocity Management Console, and then open it up in something like Excel so that you can apply filters and sorts and all that sort of stuff. So again, very easy also with Diskeeper to see which machines are getting the most benefit from the software, which ones maybe not so much because they are a bit limited on RAM. And then you can figure out, do I need to add more RAM to these machines to get more performance gain, because these are the servers that I really want to care about. You can also print this data to a file or save it as a PDF document. So let me go ahead and do that. I'll save that to the desktop here. Let's close that off now. So now Here we go. There's that benefit summary report I just saved, so I'll open that up. Yeah, it's a PDF, but it'll be okay to open up in Chrome. You could, of course, use Acrobat Viewer or some other PDF viewer if you wanted to. So here's all of that dashboard data in a simple-to-read PDF document. And there's all the graphs there as well. So hopefully that reporting has, it's an improvement for you. Certainly it allows you to get a lot more granular and really delve into what both products are doing in the environment. Keep in mind, of course, you have the very latest engines in that in those versions, which will really give you the most performance boost, as long as you are providing the software with the right amount of resource to make it work. And if ever you're not sure about that, you are all really welcome to reach out to me directly and have me help you with that, or one of the other engineers as well, if you don't want to talk to me. But, so let me stop sharing my screen here, and we'll see if we've got any questions that have come through, and see if we can answer them. Okay, so Piero says great performance, but in the new version of Diskeeper and Vlocity is present a better way to align Active Directory with the management console. I think I know what you're talking about there. In my opinion, in my honest opinion as an engineer, I don't think it's good enough yet. I think we can do a better job of integrating with Active Directory. Of course, we already integrate with Active Directory, and it will periodically do an LDAP scan to find out if new machine objects have been added that we need to include in the tree. And of course, you can expand that tree out into the organizational units. What it won't do is say, oh, we knew about these machines, but they now no longer exist in the Active Directory because they've been removed or what have you. They will still exist in the management console. There is a way of manually removing them from being in the management console, but they won't automatically be removed. So that is something that we're aware of, and we do want to improve the interfacing between Active Directory and both versions of our software. So yeah, that will, I'm sure, be coming in a future release, but hopefully you would agree with me that the features that I've shown you today, especially the no reboot, was something that we wanted to get out and allow our customers to use. We didn't want people to wait for that while we made improvement to other things. We thought this was a big enough change and a big enough improvement to get this software into the hands of people. Hopefully you agree with that. So let's see if there's any other questions that have come through. I can't see any, so hopefully that means I've done a reasonable job of explaining everything and whetting your appetite. What I'll do very quickly is I'm going to put my email address in the chat box. Let's send that to everybody. So my name is Spencer Allingham. As I mentioned at the beginning, I'm the technical director for Conducive for the Europe, Middle East, and Africa region. But those of you that have used me in the past now, I'm more than happy to help anybody from anywhere in the world. Here's my email address, sallingham@conducive.co.uk. There we go, that's in the chat box. Copy and paste that if you want to reach out to me. You're more than welcome. If you have any questions about the new versions that you perhaps didn't want to air here, if you want any help downloading, installing, making sure you're getting the most from the product, very happy to help you with all of that. So please feel free to reach out if I can be of any help. Otherwise, it just remains for me to thank you all very much for your patience listening to me waffle on and your time today. I do hope this session has been useful and look forward to speaking to you all again in the future. Thanks, everyone. Take care. Cheers.